In this section, we will cover safety procedures and precautions, hub removal and disassembly, and review inspection and failure analysis to help prevent recurrences of component failure and optimize wheel end life. It is recommended to perform a detailed inspection of all vehicles every year or every 100,000 miles. This will help determine whether the wheel end is in good condition or in need of service. You can download a complete 12-month inspection checklist at www.vsm.skf.com. Additionally, the SKF Wheel End Maintenance Guide, literature number 457975, is a great resource for visual references and explanations. When performing an inspection, always follow the vehicle and component manufacturer's safety guidelines. To avoid serious eye injury, always wear safe eye protection when performing vehicle maintenance or service, and wear protective clothing as needed. First, put the vehicle in park and block the wheels to prevent rolling. Then, raise the axle until the tires are off the floor. Place safety stands under the axle frame. For your protection, always use jack stands or a proper supporting device. Jacks can slip and fall over, resulting in serious personal injury or damage to components. If the axle is equipped with spring brake chambers, following the manufacturer's instructions, carefully compress and lock the springs to completely release the brake. Warning: sudden release of compressed air can cause serious personal injury and damage to components. Verify that no air pressure remains in the service chamber before you proceed. Once you have taken all safety precautions, start the inspection by repeating the steps in the preventative maintenance inspection section covered in the previous chapter, in which we also covered component handling and storage, pre- and post-trip inspections, and driver and shop external inspections. Now we will take a closer look at the hub. Before disassembling the wheel end, first you need to check to make sure a wheel repair is needed. First, take a sample of lubricant and examine it for color, smell, and contamination. A dark color and burnt smell could indicate elevated temperatures. A shiny or metallic appearance could indicate metal debris. A watery or milky-colored lubricant could indicate external contamination. Whenever lubricant displays these conditions, inspect bearing races and cones for signs of wear or damage and replace as needed. Do not reuse lubricant. Be sure to clean the hub thoroughly and dispose of removed lubricant properly. You can refer to www.vsm.skf.com for technical tips on how to use lubricant condition to diagnose component failure. Also, TMC RP644 Wheel End Conditions Analysis offers pictures and explanations to help identify lube conditions and their cause. On manual adjusted systems, it is recommended to check bearing end play. The TMC recommended end play range is 1/1000th to 5/1000ths of an inch. If there is no movement, or if the end play is greater than 5/1000ths of an inch, the bearings could be damaged and need further inspection. ConMet preset or LMS hub assemblies require service at 500,000 miles or every second brake service for on-highway vocations. In more severe duty applications, service may be required more often. Consult the ConMet website at www.conmet.com for more information. After you've inspected the lubricant and end play and determined a wheel end repair is needed, you will next remove the wheel and hub. Be sure to observe all warnings and cautions provided by the vehicle and component manufacturers to avoid serious personal injury or damage to components. If your wheel end contains SKF lug lock mechanisms, pry 2 or 3 to the edge of the nut using a screwdriver. Do not pry on the locking wing area. Working in a circular manner, pry off the remaining lug locks with your fingers. If a lug lock is damaged, replace it during reassembly. Remove wheel nuts and discard any that need replacement. Remove the wheels and rims with a wheel dolly. Remove the brake drum, taking extreme caution. Next, place a bucket below the hubcap to catch the oil or grease. Remove the hubcap or drive axle shaft. Now examine the spindle nut. Determine the type and disengage. Warning: do not reuse a spindle nut that has been loosened by a hammer, drift, or chisel. Damage could occur, and reuse could result in dangerous wheel-off conditions and possibly cause personal injury or property damage. Inspect for damage. Set aside or discard. Next, remove the outer bearing and set aside for later inspection. Carefully pull the hub off of the spindle. If part of the seal remains on the spindle, tap off, being careful not to damage the spindle during removal. Place the hub on a work surface seal side up. Take care not to damage the ABS ring during handling. A brake drum makes for a good stand and provides stability to the hub while working on it. Using an SKF SRT1 seal removal tool, remove the seal from the hub and discard. Do not use a handle extension. After removing the inner bearing cone, inspect and set aside. Examine the races in the hub. If there is evidence of wear or damage, remove and discard. If either is damaged, replace both in sets. Keep in mind which bearing goes with which wheel. For example, if the bearing came off the right rear, it goes back on the right rear. It is important not to mix races and cones due to the matching wear patterns of the components. This is important if you are not replacing the bearing sets. If there is a spacer present, that means the hub assembly is a preset or LMS design. Remove the spacer and inspect ends for wear. If there is wear or etching present, replace it and closely inspect both bearing sets and replace as needed. There is a precise dimension between bearings that must be held. Always rebuild a hub to original OEM specifications to ensure targeted bearing life is achieved. When removing races from an aluminum hub, with an arc or wire welder, weld a large bead around the bearing surface of the steel race and allow the assembly to cool. Then, remove and discard the bearing race. Never reuse a race removed from a hub. If welding is not possible, heat the hub to 300 degrees Fahrenheit and pound out the race with a press or hammer and drift, taking great caution not to damage the hub. The drive hub has guide holes to punch out the old races. Take care not to damage the hub. When removing the races from an iron hub, take extreme care not to damage the hub bore. Be sure to repair any damage before installing new races. Refer to the hub manufacturer's instructions first. A bearing puller or press are likely to cause damage. If these are not available, then a soft bar may be used. Warning: hardened drifts or punches can chip and damage the hub and potentially cause personal injury. Then, inspect the bearing bore for evidence of race rotation or other damage. Replace the hub if needed. Now it's time to clean, dry, and carefully inspect the bearings. When cleaning bearings, be sure to use a non-flammable solvent bath that has a filter system. Do not allow bearings to sit on the bottom of the container where debris settles. Do not clean, ground, or polish parts in a hot solution tank or with water, steam, or alkaline solutions. Using these solutions on components will cause corrosion. Caution: never rotate an unlubricated bearing or spin it with an air gun. Once clean and dry, examine carefully for wear or damage. During inspection, check for scoring, spalling, discoloration, and damage. If either race or cone require replacement, replace both. If the bearing is to be reused, carefully protect the bearing by wrapping it with a clean cloth. Also, clean the hub cavity with a degreaser. Use an emery cloth and completely wipe the hub dry so not to dilute wheel end lubricant. Check that the hub is free of contaminants and the seal bore is smooth and free of burrs or scratches. The hub is now ready for reassembly. Next, we will cover reassembly. But first, test your knowledge on this section by taking this short quiz.